Good morning, dear students. I hope all of you are doing fine. So this is our 12th video lesson of class 9 physical sciences. So let's start with our today's class. Okay, students? Right. So students, here is a picture shown in the slide. So what do you think you can observe from this picture? What comes to your mind when you observe this picture? Yes? Right. You can see that this astronaut who is in the space cannot hear a sound, right? So there is no sound in the vacuum because there is no medium, right? We have studied in our previous class in the topic of propagation of sound that medium is required for the propagation of sound. So if there is no medium, then there will be no sound, right? So students, there are two persons, right? Let's call him A and let's call him B. Okay, so who do you think will hear the sound of this siren quickly? Yes, the sound of this siren will reach which person? Will it reach A or will it reach B faster? Tell me, students. Yes, what do you think? Okay, right. So there are lot many confusing answers. So then what I will do, I will just start teaching and then I will ask this question once again. Okay, students? Right. So now students, you see that this boy is beating this table and the sound waves are transmitted in this direction and reaching the ear of this person. Okay, so students, we have saw that there are basically three states of the matter, and those three states are what? Those three states are solids, liquids and gases, right? And when we describe some basic characteristics of solids, liquids and gases, we say that the particles are very closely packed in the case of solids. In the case of liquids, the particles are not so densely packed, and in the case of gases, the particles are almost loose, right? They are at a very great distance to each other, right? So you can see in this picture also the solids are arranged together. In this picture, the solids are loosely packed, and in this picture, these are having more intermolecular space in between them. Okay. So now, students, when we say about the speed of the sound in different medium, we know that the sound propagates through a medium at a finite speed, right? The sound propagates through a medium at a finite speed, means the speed of the sound in a particular medium will remain the same, right? So the speed of the sound is dependent upon some properties. And what are those properties? So like suppose uh, the speed of the sound will depend upon the temperature of the medium, right? The speed of the sound will depend upon the temperature of the medium, right? And when we go from solid state to gaseous state, then what will happen? We can see that the speed of the sound will decrease, right? Yes, students? Right. So now let's proceed ahead. Students, in this chart, you can see the speed of sound in different media. For example, when you will see the speed of sound in the case of aluminium, you will find it to be 6420 meter per second, right? So aluminium is a solid. Now let's see the speed of sound in the case of liquid. In the case of liquid or in the case of seawater, it is 1531 meter per second, right? And in the case of gases, let's take an example of air. So in the case of air, it is just 346 meter per second, right? Although it may change a little bit, but it won't change much. So it is approximately fixed here, right? It can change based upon the various properties like we saw about temperature, we saw about humidity. So it can change on those factors as well. But generally it is taken as 346 meter per second. So student, what I want you all to observe is that there is an order of magnitude more there is an order of magnitude more in the cases when we compare the speed of sound in between gases and the solids, right? So when we compare the speed of sound in between the solids and the gases, then there is what? Then there is an order of magnitude more differences in between them, right? So we see that the sound travels faster in the solids than in the gases or the liquids, right? So when we arrange, then the sequence will be, first of all, there will be solids, which will be the fastest. The sound will travel the fastest in the case of solids. Then there will be liquids, right? And after that, at the end, there will be gases, right, students? So this is the order. And students, when we will see about this picture, when this picture reminds us of the experiment that was conducted, the bell jar experiment, and this bell jar experiment proved that the sound requires a medium to travel, right? Yes. So now students, there is a quiz for you. So first of all, what you need to do is that you need to arrange the matter according to the speed of the sound. Okay. So first of all, see, aluminum, I have numbered it as 1, air I have numbered it as 2, and alcohol it is numbered 3. So what will be the correct sequence for this? Okay, so we can say that aluminum will come at the first place because it is a solid. The speed of the sound will be maximum in the case of aluminum, right? Now, less than it, there will be alcohol because alcohol is a liquid, right? And after that, what will come? It will come air, right? So the correct sequence will be aluminum, alcohol, and then it will be air, right? So now students, there is a second question. So read this question. The question reads, the speed of the sound depends upon the temperature of the medium, right? The speed of the sound depends upon the temperature of the medium. So is this statement true or false? Yes, my dear students? Yes. So this statement is a true statement, right? This statement is a true statement that the speed of the sound depends upon the temperature of the medium. Okay. So now let's proceed ahead. Students, what you can see in this picture? Yes, my dear students, this is a mirror. This is a torchlight. Okay. So what else can you see in this picture? So we can see that light is getting reflected. Okay, students, that the light is getting reflected. So can we say same for the sound also? Can we say that sound is also getting reflected? Yes. Okay. See students, here there is a stopwatch, right? And there is a cardboard tube here, right? And there is a softwood and this is a hard plywood. So now this experiment goes as, first of all, the stopwatch will start ringing, right? So the sound will travel in this direction. And if the sound is being reflected, then this person will be able to hear the sound through this cardboard, right? So this is the experiment, right? So now we have saw that sound is getting reflected, right? So there should be some laws that governs the reflection of the sound. And if you students have learned the laws of reflection, then it will be very easy to understand. Otherwise also, let's just look at the laws of the reflection of sound, right? So the first law states that the direction in which the sound is incident and is the reflected makes the equal angle with the normal to the reflecting surface at the point of incidence, right? So this, the first law states that the angle of incidence, which is what? In angle of incidence is the angle between the propagation of sound and the normal drawn to the surface, right? So this angle I will be equal to angle R, right? So the angle of incidence of sound will be equal to the angle of reflection of sound, right? The next point is that the incident ray, the normal, the incident sound wave, the normal, and the reflected sound wave, all these three will lie in the same plane. Okay, it's understood, students? These all three will lie in the same plane, right? So now, students, the sound bounces off the surface of the medium, and this can be of what? This medium can be solid or liquid, right? So in order to make reflection of sound to occur, the surface can be of large size or can be either rough or polished, right, students? So sometimes what happens when we are trying to reflect the sound wave can bounce off to the other surface, right? So in order to make the sound get reflected, what we need to do, we can make the surface of large size and we can either keep it rough or polished, right? Okay, students? Right. So now there is a quiz for you. So the question for this quiz is, that angle of incidence of sound is 30 degree. Okay, the sound is getting incidented at 30 degree. So what will be the angle of reflection in this case? Okay, so now I'm giving you 10 seconds to think about this question, then I will ask you this question. Okay students, right. So the answer will be the angle of incidence is 30 degree, and from the laws of reflection we know that the angle of incidence, angle I will be equal to angle R, right? Angle I will be equal to angle R. Since angle I is 30 degree, angle I equals to 30 degree, therefore angle R will be also equals to 30 degrees. So the B option or the option B is correct, that is 30 degree is the correct answer. Okay students, so now let's move ahead. Students, what you are observing in this picture? Yes students, right. In this picture we can see that this person is speaking something and the sound waves are traveling in this direction. It is getting bounced off in this direction and then it is again getting back to this person, right? So what is happening? The reflection of sound is happening. Yes? Okay. So the reflection of sound is happening? Right. What do we call this type of reflections? Yes, this we call this type of reflections as echo, right? We call this type of reflections echo, right? So now let's move ahead. Students, we have saw that the speed of sound is approximately between 334 meter per second to 346 meter per second. But now just assume that the speed of the sound is 334 meter per second. Okay, and we know that the persistence of human hearing is 0.1 second. So what is persistence of hearing, students? So the persistence of hearing is that thing means our brain is able to differentiate between the two sounds only if it has reached our brain at the interval of 0.1 seconds, right? So now can we use this data to find that how much distance is actually required for us to actually hear an echo? Yes, students, can we do that? Okay, now let's try to do that. Okay, students, so now let the distance from you and object be x, right? So for you to hear, this sound, what you will see, for you to hear this sound echo of the wave has to travel double the distance, right? Suppose you are standing here and here is the wall and you are producing the sound. So sound first needs to travel in this direction and then again the sound needs to travel in this direction, right? So the sound wave has to travel double the distance of to reflect back, right? So according to the question, right? So we have taken the velocity here as 330 meter per second for the sake of simplicity, right? We have just taken the speed of the air sound in air as 330 meter per second, right? So when we are taking it as 330 meter per second, for then what will be? We can equate this as 2x, that is the distance for that the sound will travel, right? So distance will be what? It will be 330 into 0.1, right? So the value of x will be what? The value of x will be 17.5 meter per second, right? So value of x will be 17.5 meters, not meter per second. This per second is wrong. So it will be 17.5 meters only, right? So for us to hear a successful echo, the object should be around 17 meters distance to us. Okay, students, right? So now let's proceed ahead. Right. So what is the minimum time period for echo? Students, what should be the minimum time period for echo? Or I can reframe this question as what is the persistence of human hearing, students? Yes, the persistence of human hearing is 0.1 seconds. Right. So now students, you tell me that what is the minimum distance of obstacle from the sound to the source or from the source to the sound? What should be the minimum distance between the obstacle and the source if we have to find the echo, right? As we have calculated, it should be around 17.5 meters, right? So it should be 17.2 meters, right? Okay. So now let's just recapitulate what we have studied in our today's class. So in our today's class, what we have studied? We have studied about the speed of the sound in a medium, reflection of sound, and echo. Okay, students? So now let's compare the speed of sound in solid, liquid, and gases. So students, we saw that the speed of the sound in solids is more than the speed of the sound in the liquids, and the speed of the sound in liquid is more than the speed of the sound in the gases. Okay, students, understood this point? Yes. So students, how can we explain the reflection of the sound? Right. So students, the reflection of the sound can be explained very easily by the term called echo. Right. What is an echo? When we produce a sound, what happens? The sound propagates in a particular direction, and after it has hit any obstacle, then what it does? It reflects back to us. Right. So that explains the reflection of sound. Yes? Okay. So students, what is an echo? Echo is the reflected sound that we hear after it has been reflected from any obstacle. Okay, students? Right. So what should be the minimum distance from the object to the source for echo to happen? The minimum distance can be around 17 and 17.5 meters. It depends upon the speed of the sound. The persistence of human hearing will be the same. It will be around 0.1 seconds. So the speed of the sound will determine how much distance it is there. So if we take 330 meters per second, then the minimum distance will be around 17.5 meters. And if we take the speed of sound as 346 meters per second, then it will be around 17.2 meters. Right, students? Okay. So now, what are the conditions necessary for the echo to happen? Right. So the conditions necessary for the echo to happen are, first of all, there should be a source of the sound. Right. There should be an obstacle. Right. And the reflected rays and the incident rays should be in the same plane. Understood, students? Right. So can we justify this statement that sound follows the laws of reflection? Yes, students, can we justify this statement? Yes. So we can justify this statement by doing a very simple experiment wherein we are speaking in a cardboard tube, and that cardboard tube is doing what? It is just reflecting the sound back at a particular angle, right? So when the angle of incidence will be equal to the angle of reflection, then we will be able to hear the sound, right? So the sound follows the laws of the reflection as the angle of incidence is equal to the angle of reflection, right? first first law, and after that the second law of reflection, which is the incident ray or the incident sound wave, the reflected sound wave, and the normal drawn to the surface will always be on the same plane. So that is also being followed by the sound. Okay, students, do you agree with me? Yes. So this is what we have studied in our today's class. I hope everything is clear to you. So if there is any problem, you can still ask me. Yes? No problems are there? Right. That is very good to hear. So now let's move ahead. Okay, students? Right. So students, this is the homework for you. What you have to do, there is a question, right? The echo is heard in 3 seconds, right? The echo is heard in 3 seconds. So what is the distance of the reflecting surface from the source? You need to find the distance of the reflecting surface from the source when it is given that the speed of the sound is 342 meter per second. Okay, students? So this is your first question, that an echo is heard in 3 seconds and the distance you have to find, the speed of the sound is given as 342 meter per second, right? This is your first homework, and your second homework is that you need to explain the reflection of sound. Okay, students? So this is your second homework, right? So now I don't think so if there is any problem. But if still there is problem, I'm giving you 5 seconds to quickly ask those questions, ask those doubts. Okay, right. So now that's all for this class. So I wish you all the best for today's class. So thank you everyone.